This is Miss Samra. I'm back with my next lesson, and today's lesson is on 9-4. Again, 9-4, and basically chapter 9 and 10 is all about trigonometry. So I'll be trying to kind of touch base every single concept you needed to know. So it's going to be kind of quick review on everything we have done last year in trig class and over summer. So anyways, today's lesson is more about all 6 functions. So all 6 trig functions. As we talked about in last video, we have 6 different functions. First 3 are just normal function, and rest of the 3 functions are just reciprocal of first 3 functions. So in order to write all 3 functions, which is sine, cosine, tangent, cotangent, secant, and cosecant, you mainly have to have 3 different things. If you have opposite side, adjacent side, and hypotenuse of that triangle, yes, you can write all 6 ratios with an ease. Or if you have x, y, and r in that triangle, yes, you can write all 6 ratios. But let's just say if any of the variables missing, any of these 3 variables is missing, then it's still possible to solve for that missing variable. You could just use Pythagorean theorem. You could just use x squared plus y squared, and it's equal to r squared. So plug in for whatever you know and solve for the missing one. So you could do that too. So that was just the first thing. Now next, this is something interesting. I hope you remember this. So once you have all 4 quadrants, so you know first quadrant that goes from here to here, 0 to 90. Second goes from 90 to 180. Third one, 180 to 270. And the fourth one is 270 all the way back to 360. What about all 6 functions and their signs? So sines and trig functions or trig ratios. So what's the relationship? If your angle of that triangle is in first quadrant, what happens to all 6 ratios? I hope you remember this we used to say something just to kind of remember the whole pattern. So I would say add sugar to coffee. Oof, what I'm writing. My bad. Add sugar to coffee. Okay, what is that? So let's talk about that. Again, I assume you should know that, but if not, still again, I'll just review that kind of quick. So let's just say if I have add in the first quadrant, it means I'll borrow A from this. That implies that all ratios in this quadrant will stay positive. When I get to second quadrant, so we're just going to borrow this S from sugar. It means sine and its reciprocal, which is cosecant, would stay positive, and rest of the ratios would be negative. When it gets to third quadrant, so we're going to borrow T from 2, which means tangent and cotangent would stay positive, and rest of the ratio is going to be all negative. And the last one, we'll borrow C from coffee. It means cosine, and its reciprocal, which is secant, would stay positive, and rest of the ratio is going to be, again, I'm not going to go in detail. You know, we already talked about like why it's negative, why it's positive. So that's going to be too much in detail. We're not doing that. So the only thing you needed to know is add sugar to coffee, and based off that, you can determine sign of that trig function. Okay, let me give you a few more examples on how to identify what quadrant your angle is in. So let's say if I ask you, okay, I have sine theta, sine ratio less than 0, and cosine theta is bigger than 0. So do you think you could figure out what quadrant I'm talking about, or what quadrant my angle is in? Okay, so based off these inequalities or restrictions, I need to determine the quadrant. When I say sine theta is less than 0, it means sine ratio is negative. When I say cosine is positive, bigger than 0 means cosine is positive. Okay, let's see which quadrant works for both of these restrictions. So I'm just going to take one at a time, and I'm just going to put a check mark for a quadrant that applies to that inequality. Sine is less than 0. Sine is negative in here and in here. I'm done with my first inequality. Now let's check the second one. So I'm already down to third quadrant and fourth quadrant. And I need to check which one of these two quadrants work for this inequality. So cosine needs to be positive. So which one of these two quadrants would give you positive cosine? It's this one, so that's my answer. So my angle is in fourth quadrant. So let me show you one more. Let's say, again, if you don't understand, you can pause the video, you can go back and replay it. So let's say if I have secant theta is less than 0 and tangent theta is bigger than 0. All right, so let's draw this out. Let's take one inequality at a time. So secant theta is less than 0 means secant is negative. Secant or cosine is the same thing. So that's negative in second quadrant and third quadrant. Now I'm down to these two options. So tangent stays positive. So which one of these two options would give you positive tangent? Down this one, so it means my angle is in third quadrant. Here you go. All right, now let me show you an example on how to find, hold on, I still have to talk about some identities. So let's talk about those identities first. Some relationships, some identities you needed to know. So first one is called a reciprocal identity. Reciprocal identities. This identity is actually based off the reciprocal relationship. So I know sine theta is a reciprocal to cosecant. So I would have 1 over cosecant theta. That's the first reciprocal identity. Then I have cosine theta is equal to 1 over secant theta. And then tangent theta is equal to 1 over cotangent theta. So this is for first three, and if you just want to figure out the rest of those, it's pretty much the same thing, but just flip the fraction. If I do cosecant, you know this is going to be 1 over sine theta. Same thing for the rest of these. Okay, that's a reciprocal identity. Then I have quotient identity. So quotient identity, I have two. So tangent is equal to sine theta over cosine theta. And cotangent theta is equal to cosine theta over sine theta. And the last one is Pythagorean identity. Oh, my bad. Pythagorean identity. Pythagorean identities. We have three different ones. So the first one is sine squared theta plus cosine squared theta. It's equal to 1. Second one, I have 1 plus tangent squared theta is equal to secant squared theta. And the last one is 1 plus cotangent squared theta is equal to cosecant squared theta. If you remember last year, we talked about this, like every single identity can be written in 3 different ways. All right, so total you'll have 9. If you just manipulate all these functions, you can come up with 9 different identities you can use to simplify your functions. Okay. Anyways, if you want to look at your, you want to find these identities in your textbook, all of these are on page number 568. Now, let me show you an example on finding all trig ratios. So let's say I have one of the trig function given in the problem. So sine theta is 2 over 3. That's what I know. And there's another information that's given in the problem is, it's cotangent theta is less than 0. And this is all I know. And my question to you guys is to solve for remaining trig functions. Rest of those 5 trig functions. So what I'm going to do, just to make it easier, I'm going to list down all the functions I have. So I have to solve for cosecant theta. I have to solve for cosine and secant. I'm just going to put it sideways because I know these are reciprocal to each other. So I would have tangent, and this is cotangent. Now the reason I put cosecant first, because I already know sine function. If I just flip the fraction, that would be cosecant. So it would be easier to solve for that. But isn't it you have to have the quadrant for these trig functions? You really have to understand, like you really need to determine what quadrant this angle is in, because based off that quadrant, you need to put signs in front of every trig function. We still have to do that. So first, I'm just going to figure out all the trig ratios, and then I'll figure out the quadrant and we'll put the sign in front. Okay, so sine function is 2 over 3. So cosecant would be 3 over 2 because it's just a reciprocal. Okay, but I hope you remember, in order to write these ratios, you have to have all three variables. I have to have x, y, and r. Okay, so if you know sine function, it means you already have y and r out of these. So you still have to solve for x. This is where you need to solve. You need to use Pythagorean theorem, and you need to solve for the missing one. So let's just say I have x squared plus y squared is equal to r squared. X is missing, y squared is 2, 2 squared 4, r squared, which is 3, and I would put 9, and x squared is 5, and x is equal to radical 5. Here you go. So now I have x value, so I can write down cosine function. Cosine is x over r, which is radical 5 over 3. If I know cosine, I can flip the fraction and I can write secant. So I would do 3 radical 5. Oh, we cannot have radical in the denominator, so we need to rationalize. So if I do that, so my ratio would be 3 radical 5 over 5. Tangent, it's y over x, so that would be 2 over radical 5. If I rationalize, it would be 2 radical 5 over 5. Cotangent would be, I'm just going to flip this fraction, it would be radical 5 over 2. All right, I'm almost done, just 10% left. I just need to put negatives. How do we do it? That's based off what quadrant this angle is in. Okay, how do we do that? We need to look at those inequalities. Sometimes in some of the problems you will see quadrant right away, but if you see inequalities, then you actually have to look at every inequality. Based off that, you need to figure out the quadrant. Okay, I see cotangent is less than 0, means it's 0. So cotangent is negative in this quadrant and this quadrant. So second and fourth quadrant. But I don't see any other inequality. But instead of another inequality, I see sine function, which is already positive in here. So I already know sine is positive. So out of these two, which one of these two quadrants would give you positive sine? It's this one. So I know my angle is in second quadrant. So based off that, I need to put negatives or positive in front. So second quadrant means as sugar. So sine and cosecant would stay positive. So sine and cosecant would stay positive, and rest of the ratios, I'm just going to put a negative in front. And yeah, that's pretty much all. So this is how we do it. So if you still feel like there's something you don't understand, just pause.